Thin linear antenna, and the antennas are symmetrically fed at the center by a balanced two-wire transmission line, and it is assumed that the current distribution is sinusoidal. Current distribution measurements indicate that this is a good assumption provided that the antenna is thin. That is, when the conductor diameter is less than, say, lambda by 100. Consider the figure to develop the far-field equations for a symmetrical, thin, linear, center-fed antenna of length L. The current at any point Z on the antenna referred to a point at a distance S, is I is equal to I naught sine I is equal to I naught e to power j omega t minus r by c into sine of 2 pi by lambda L by 2 plus or minus z, where sine of 2 pi by lambda of L divided by 2 plus or minus z is the form factor for the current on the antenna. The expression L by 2 plus Z is used when Z is negative, and L by 2 minus Z is used when Z is positive. Far fields for center-fed dipoles are H phi and E theta. H phi is equal to J I naught divided by 2 pi r cos of beta L cos theta divided by 2 minus cos of beta L by 2 divided by sin theta. E theta equal to J 60 I naught divided by r cos of beta L cos theta divided by 2 minus cos of beta L by 2 divided by sin theta. We know that E theta is equal to 120 pi into H phi. Radiation resistance of lambda by 2 antenna. The far field components are E theta and H phi, so that the radial component of the Poynting vector is SR is equal to half of real value of E theta and H phi. We know that E theta is equal to 120 pi into H phi. Therefore, radial component of the Poynting vector is half of real value of h phi into 120 pi into h phi. Therefore, radial component is equal to radial component of the pointing vector is equal to 60 pi into observed value of the magnetic field, square of the observed value of the magnetic field. Magnetic field of antenna is given by J I naught divided by 2 pi r cos of beta L divided by 2 cos theta minus cos of beta L by 2 divided by sin theta. When L equal to lambda by 2, the length of the antenna is lambda by 2 because we are finding the radiation resistance of lambda by 2 antenna. Then beta L by 2 is equal to 2 pi by beta is 2 pi by lambda into L by 2, which is equal to 2 pi by lambda. L is lambda by 2 divided by 2, which is equal to remainder is pi by 2, and I naught is equal to I naught e to the power j omega t minus r by c. I'll write here. I naught is equal to I naught e to the power j omega t minus r by c. Therefore, absolute value of h phi is equal to I naught divided by 2 pi r cos of beta L by 2 is pi by 2 cos theta minus cos of pi by 2 is 0 divided by sin theta. Now substitute the absolute value of the magnetic field equation in the radial component of the Poynting vector equation, that is 60 pi h phi square, which is equal to 60 pi and I naught divided by 2 pi r cos of pi by 2 cos theta divided by sin theta square of it. Radiated power is given by integral of radial component of the Poynting vector over the sphere, which is equal to phi equal to 0 to 2 pi, theta equal to 0 to pi, SR is 60 pi I naught divided by I naught square divided by 2 pi r whole square cos square pi by 2 cos theta divided by sin square theta into ds, that is r square sin theta d theta d phi. From the previous line, radiated power is equal to 60 pi divided by 4 pi square into I naught square, phi equal to 0 to 2 pi d phi, theta equal to 0 to pi cos square pi by 2 cos theta divided by sin theta d theta. Therefore, radiated power is equal to 15 I naught square divided by phi. Phi, the integration of d phi is equal to phi, limit 0 to 2 pi, theta equal to 0 to pi cos square pi by 2 cos theta divided by sin theta d theta, which is equal to 15 I naught square divided by pi into 2 pi, theta equal to 0 to pi cos square pi by 2 cos theta divided by sin theta d theta. Therefore, radiated power is equal to 30 I naught square 0 to pi theta equal to 0 to pi integration of cos square of pi by 2 cos theta divided by sin theta d theta. Let cos theta equal to u, then d theta equal to minus du sin theta divided by sin theta. When theta equal to 0, u equal to 1. When theta equal to pi, u equal to minus 1. When I substitute these values, radiated power is equal to 30 I naught square integration of cos square of pi u by 2 u divided by 2 divided by sin theta divided by sin theta d theta is equal to minus du divided by sin theta. Limit 1 to minus 1. Therefore, radiated power P is equal to 30 I naught square minus 1 to 1 cos square of pi u by 2 divided by sin square theta du. We have considered cos theta equal to u, and we know that sin square theta equal to 1 minus cos square theta. Therefore, we can say that sin square theta equal to 1 minus u square. When I substitute this to radiated power equation, that is 30 I naught square integration of cos square of pi u by 2 divided by 1 minus u square into du. Limits minus 1 to 1. And 1 by 1 minus u square is equal to half of 1 divided by 1 minus u plus 1 divided by 1 plus u. After substituting 1 by 1 minus u square in the radiated power equation, we can write the radiated power equation as 30 I naught square divided by 2 integration of cos square of pi u by 2 divided by 1 minus u du limit minus 1 to 1 plus integration of cos square of pi u divided by 2 du divided by 1 plus u limit minus 1 to 1. Radiated power is equal to 15 I naught square cos square of pi u by 2 1 minus u du plus minus 1 to 1 cos square of pi u by 2 du 1 plus u. Let 1 minus u is equal to v by pi for u equal to pi minus v divided by pi. Therefore du equal to minus dv by pi. When u equal to minus 1, v is equal to 2 pi. U equal to 1, v equal to 0. Similarly, consider 1 plus u is equal to v dash by pi. U equal to v dash minus pi divided by pi. Du equal to dv dash by pi. When u equal to minus 1, v dash equal to 0. U equal to 1, v dash equal to 2 pi. Therefore, radiated power is equal to 15 I naught square integration of cos square of pi u or u is pi minus v divided by pi into pi by 2 divided by v pi by pi minus dv by pi plus integration of cos square of v dash minus pi divided by pi and pi by 2 divided by v dash divided by pi dv dash divided by pi. Limit in the first case 2 pi to 0, in the second case 0 to 2. From the previous line, radiated power is equal to 50 I naught square integration of cos square of minus v minus pi divided by 2 divided by v dv integration 0 to 2 pi plus integration of cos square of v minus pi divided by 2 divided by v dash minus pi divided by 2 divided by v dash into dv dash integration limit 0 to 2 pi. The same above equation I can write by the equation 59 square into 2 integration of 0 to 2 pi cos square of v minus pi by 2 divided by v in, into dv. Since we know that cos square of minus theta is equal to cos square of theta, and we have applied one more concept, that is integration of x dx when the limit a to b is equal to integration of y dy when the limit same as previous same as the left hand side, that is a to b. We know that cos square theta is equal to 1 plus cos 2 theta divided by 2. Cos square of v minus pi by 2 is equal to 1 plus cos 2 into v minus pi by 2 divided by 2, which is equal to 1 plus cos v minus pi divided by 2, which is equal to half minus cos v by 2. Since cos theta minus 180 degree is equal to minus cos theta. Therefore, I have written here cos of v minus pi is equal to minus cos v. Therefore, radiated power is equal to 50 I naught square into 2 1 minus cos square of v minus pi by 2 divided by v is 1 minus v minus cos v divided by v dv into divided by 1 by 2, so divided by 2, limit 0 to 2 pi. Therefore, radiated power is equal to 15 I naught square integration of 1 by v dv limit 0 to 2 pi minus integration of cos v divided by v into dv limit 0 to 2 pi. Using Euler's theorem, integration of cos v divided by v into dv for a limit 0 to 2 pi is equal to log v minus v square divided by 2.2 factorial plus v to the power 4 4.4 factorial minus and so on. When I use this in the above equation, I will get 15 I naught square into integration 1 by v for a limit 0 to 2 pi is log v minus integration of cos v divided by v dv for limit 0 to 2 pi is log V plus V square divided by 2.2 factorial minus V to the power 4.4 factorial plus 6 and so on. Therefore, P equal to 15 I naught square log V cancels, and this is equal to 2.41. Radiated power P must be equal to the square of the RMS current flowing on the antenna with a radiation resistance. Therefore, radiated power P, that is 50 I naught square into 2.41, which is equal to square root of the RMS value of the current into radiation resistance. Therefore, radiation resistance is equal to 30 into 2.41, which is equal to 73 ohm. So radiation resistance is equal to 73 ohm is the radiation resistance of lambda by 2 antenna.